Alright, so this is what I was trying to say yesterday. The relationship between length and area and volume. We looked at an example. So let me talk to you, Kayla, since you were the one person that wasn't here yesterday. And everyone else can get a review by me talking to you. For example, Kayla, say if the length was 3. If I made a square for area using these same lengths, can you tell me what the area of this would be?
9.
The area is going to be 9. Okay, and of course the reason is because this would be 3 by 3, and that's how you find the area's length times width. On the other hand, what would be the volume? Wait, so for volume, do you understand that we would do length times width times height? So it would be like 3 times 3 times 3? 27. Okay? So if the length was 3, the area would be 9, and the volume is 27. Okay? So that's basically what we're working with. Now, so everybody look at problem number 12. And focus with me so you can really absorb this. Kids were struggling yesterday, so we're giving it another shot. You should basically make this little table like I made. I shortened it. I'm trying to streamline the process and make it clear for you guys. So make this little length, area, volume table with me on your paper. So here's the deal. Keep in the back of your mind that whatever the length is, if I want the area, I square it. If I want the volume, I cube it. That's the key. Okay? So, imagine that the size of an object is increased uniformly. If the length doubles, alright, focus on that. How does the surface area change? Alright, but the length doubles. If the length doubles, it goes from being x to what? If the length doubles, that means the new length is 2x. Okay? Now, Kayla, whatever the length is, if I want the area, I square that. So if I take 2x and I square it, meaning 2x times 2x, what am I going to get for the area?
4.
That's going to be 4x squared. Okay, because x times x is x squared. Alright, so I doubled the length, but my new area is 4x squared. If I start from the length, how do I get the volume? Anybody?
4x squared times 2x.
Wait, go back to the beginning. Go back to the 2x. Everything comes from the length. So if I want the area, I square the length.
2x.
If I want the volume, what do? You cube it. Alright, if I want the volume, I cube the length. So what do I get if I cube this 2x?
8x.
I'm going to get 8x what? Cubed. 8x to the third power. Alright, have I lost anybody so far? Alright? Now look, so over here this is a summary of what's happening in each case. Of course the length was multiplied by 2. That was just given in the problem. We doubled the length. It told us that. But what happened with the area? What's the area multiplied by?
4x.
Just give me the number in the front is the multiplier. Okay, so what's the area multiplied by? No. The area is multiplied by 4, okay? Because look, the original area would have just been x squared. The new area is 4x squared. So it's been multiplied by 4. So there's nothing fancy. That number in the front, that is the multiplier. Right there in your face. Right there in front of you. Okay? So the area is multiplied by 4. Margaret, what is the volume multiplied by? 8. The volume is multiplied by 8. Can you see the 8x cubed? That's what the volume is multiplied by. The original volume would have been x to the third power. The new volume is 8x to the third power. So the volume has been multiplied by 8. Okay? Now, I encourage you to do what I did and always do the whole chart. But only one of these three statements is the answer to the question. Okay? I told you what happened with the length, the area, and the volume, just so you have the full picture. But the question is only asking about how does the surface area change. So which one of these three is the answer to the question? Right. The one that pertains to area. That's why I marked it in blue, because that's the one that's the actual answer to the question. So what happened to the surface area? It's multiplied by 4. And that's what you would write down as your answer. You would say multiplied by 4. Okay? Now, just to back that up, let me just follow through with an example. I mean, we did this yesterday, but I just want to connect it to what I just showed you. So according to us, if the length doubles, the area should be multiplied by 4. Okay? So let's test that theory. Give me any number between 2 and 6. 5. Let's just go with 5. Let's say if the original length was 5. Okay? The original length is 5. What would be the original area in that case? The original area would be 25. Right? Because that would be 5 by 5. Okay? What would be the original volume? The original volume would be 125. Okay? Because that would be 5 times 5 times 5. Length times width times height. Okay? So the original length, the original area, and the original volume. Now, according to the problem, we're supposed to double the length. So what's my new length after I double it? My new length after I double it is 10. Okay? Now, what's my new area now that I've doubled it? My new area is 100. Okay, hold on, let me pause this for a second. Okay. So the new area was 100 because that's 10 by 10. What's the new volume going to be? The new volume is going to be 1,000. Okay, because that's 10 times 10 times 10 is 1,000. Now let's see the multiplier effect. Okay, let's see, I'll go purple on it. So as far as the length, as promised, we doubled it. Alright, that's what the problem told us to do. But we're supposed to see, well, what happened with the area? Alright, so you can see 25 became 100. It wasn't doubled, that would have been 50. It was multiplied by 4. That's how it became 100. Okay? And 125. How many times does 125 go into 1,000? 8 times. Okay? So I'm just following up with an example. So we proved it in the first place with these variables. But you were kind of just taking my word for it. Okay, if you say so, that's okay. That's the multiplier. You're telling me that it's true. I'll take your word for it. But I'm hoping if you see it with actual numbers, then it's more convincing to you that, okay, I see what he's saying. It really is multiplied by 8. It really does get multiplied by 4. Okay? Go ahead and do number 13 right now. I'm going to pause. All right, so number 13. Instead of doubling the length, what's happening to the length this time? The length triples. So last time I took x, which represents the length, and I put 2x. I put 2x because we were doubling it. What am I going to put this time?
3x.
This time I'm going to put 3x to represent triple the length. X is the length. Now, please understand, everything is based on the length. I start with this 3x. If I want the area, what do I do with the 3x? I square it. Starting with the length, if I want the area, I square it. What do I do if I want the volume? I cube it. Okay? So I take the length, I square it, I cube it. What do I get if I square it? I'm going to get 9x squared. So that should be an expression for the area. What do I get if I cube it? I get 27x to the third. Okay? So, of course, the length was multiplied by 3. Okay? Because that's what the problem told us to do. What was the area multiplied by, class? The area was multiplied by 9. Alright? Because you can see the 9x squared? That's the multiplier. The original area was x squared. The new area is 9x squared. So it was multiplied by 9. Okay? Hunter, what was the volume multiplied by? 27. Now, which one of these is the answer to the actual question? Right, the bottom one. That's why I marked it here in blue to emphasize that. So on your paper, you need to write multiplied by 27. Because the question asks, how does the volume change? How does it change? Multiplied by 27. That's what you write down for your answer. Okay? Alright, I could do an example, but I'm not going to do another one. Look at number 14 with me. Imagine that the size of an object is increased uniformly. The surface area is multiplied by 16. Alright, now this is slightly different. Because the previous two problems, you were given the length to start with. This time you're given something's happening to the surface area. Okay? So, Jesus. The surface area is multiplied by 16. So I'm going to record that right here in the chart. Okay? Let's see, I didn't mean to put that mark right there. So Jesus, will this make sense to you? If the surface area is multiplied by 16, that means I have an area of 16x squared. Okay, the original area is x squared. If it's multiplied by 16, that would be 16x squared. Does that make sense? Yeah. Okay. Now, follow this with me, everybody. Because we have to sort of work backwards. Everything is still based on the length. Okay? This 16x squared had to come from a length that we squared. So, Jesus, what length could I square that's going to give me 16? 4. Okay? So the original length must have been 4x. Because that's what it would take to square it and get 16. Okay? If the original length was 4x, Burton, can you tell me what must be happening with the volume then? It's going to be cubed. So it'll help if you memorize these perfect cubes. But for right now, you can use the chart that I have written on the board. What do I get if I cube 4? 64. So the volume must be 64 x to the third power. Okay? So, even though they didn't ask me for this, what was the length multiplied by?
4.
The length was multiplied by 4. The area was multiplied by 16. That's the one that we were given. But here's the one that's the actual answer to the question. What was the volume multiplied by? The volume was multiplied by... Whoa.
What happened?
It didn't fit. Yeah. The volume was multiplied by 64. Okay? Alright, look at number 15. Imagine that the size of an object is increased uniformly. The volume is multiplied by 125. Okay, Irvin, tell me what to write on my chart.
You write for the volume 125 x to the third.
Correct. I write the volume is 125 x to the third power. That's me showing the volume being multiplied by 125. Keep going with it, Irvine. What does that tell me?
That tells you that the volume is multiplied by 100.
All right. So I need the length though, because everything is based on the length.
You cube it.
So if the volume is multiplied by 125, what must the length have been?
5.
So the length must have been 5x, because 5x would give you 125x to the third power if you cubed it. Okay? Miss Street, talk to me about the area then. 25x squared. Okay? So, Yvonne, the length was multiplied by what? 5. Okay? Denzel, the area was multiplied by... One more time? Did you say 25? Okay. The area was multiplied by 25. And of course, the volume was multiplied by 125.
Of course it was.
Okay? But that's the one that we were given. That's why I say of course. And again, only this one that I have here in blue is the answer to the question. Because the actual question said, how does the surface area change? The surface area must have been multiplied by 25. That's the answer to the question. Okay? Yeah. All right? Looking at number 16. The balloon is inflated. The circumference is multiplied by 2. Burton, the circumference is multiplied by 2. Where does that go in the chart?
Nowhere.
No, it goes somewhere. Where does it go in the chart?
It goes, what, area, length, volume.
I feel like you're guessing.
It's one of
Think about it. Circumference. Is circumference a length, an area, or a volume?
length.
It's a length.
Yeah.
Circumference is a length. It would be measured in inches or centimeters or whatever. So please understand, if we talk circumference, we're talking about length. Okay, circumference is length. So, so what am I going to put here at the L?
2.
Right, 2x. Okay. So in that case, what am I going to put at the A?
4x squared.
4x squared. Okay, and Maritza, what am I going to put at the V? 8x cubed, correct. Okay, so Kelvin, what's the answer to the question? How does the volume change? The volume is multiplied by 8. Okay? I didn't ask you for it this time, but if I had asked you for what happens to the area, you would have said multiply by 4. And of course, the length was multiplied by 2 that was given. Okay, any questions so far? All right, raise your hand if you feel like you're understanding what I'm showing you today. Okay, all right, put your hands down. Okay. All right, let's just finish this up quickly so we can get on to the new lesson. So let's see, number 17.
Me.
Who said that?
Me. I did.
Burton,
What's up?
tell me what to write.
Okay. I haven't read it yet. Okay, I'm done. Alright, so your surface area, that's going to be A.
Okay,
Right? So it's 36x squared.
okay, so 36x squared, that goes A, because that's area. Then what happens?
So you go back to the length, and it's 6x.
Go back to the length, it must be 6x, because that's what it would take to, if I square it, to get 36x squared?
And then cube the volume, which is 216.
If I cube it, cubing the length of 6x, that would be 216 x to the third power. Okay, so what's the answer to the actual question?
It's multiplied by, I'm just kidding, 216.
Is multiplied by 216. All right? Of course, if I had asked you what happened to the length, what would you have said? 6 multiplied by 6. And of course, we were given that the area is multiplied by 36. Okay? Last one. Okay. Miss Street. Okay, tell me what to put in my chart first. Oh, number 18. The size of a sphere decreases so that the diameter is halved. Okay, so you know what? First of all, which one of these three things am I dealing with? Length, area, or volume? If I'm talking about the diameter, is that length, area, or volume? That's length, okay? So if the diameter is cut in half, what's the multiplier for the length?
It's like half of 360.
Well, it's half x, because length is just x. So remember, just like when we doubled it, we just put 2x. So for half, we're just going to put 1/2 x. Okay? So if it's being halved, the multiplier is 1/2. Okay? You better look at this one.
Wait, which one?
The 18 wasn't quite right. Okay? So the multiplier is 1/2. So now, Miss Street. If I have the length, how do I get the area? If I have the length, how do I get the area? Just in general. Not double it. We square it. Remember, looking back, if I had 6, I did 36. If I had 2, I did 4. Well, that kind of would be the same as it. We're squaring it. Okay, where am I at? Okay, so if I have the length to get the area, I'm going to square it. All right, that's why area is always x squared. That's a hint to you, okay? Now, what do I get when I square 1/2? 1/4. 1/2 times 1/2 is 1/4. So for area, I'm going to put 1/4 x squared. Okay? Miss Street, one more time. Right. Given the length, if I want the volume, I cube it. So 1/2 cubed, that's 1/2 times 1/2 times 1/2. That's 1/8. 1/8 x to the third power would be my expression for volume. Okay? So getting back to the question. So class, what happened to the surface area? It was multiplied by 1/4. Alright, I didn't leave enough space for this. It was multiplied by 1/4. And what happened to the volume? It was multiplied by 1/8. Okay? Yes? Yes, you could put divides by 4. I'll take either one. The question was, could you put divides by 4 for surface area and divides by 8 for the volume? Sure. All right, any question on this?